So pass transistors. Okay. We looked at this briefly, in the initial part of this module when we wanted to figure out if you should put the NMOS on top or NMOS down, PMOS on top or PMOS down and all that. But we will look at that in little more detail now. I'm going to connect this to VDD. I'm going to connect this to VDD. Assume that this capacitor is discharged. Okay. So what's the drain and source first? VDD is drain, source. Right? Now, what happens to the source side? It will charge up to VDD minus VT. Okay. So the Vs of t, maybe I should write it here, limit t tends to infinity, Vs of t is VDD minus VT. Okay. And this is assuming I of, right, equal to subthreshold leakage. Equal to 0. Because if I of is there, then eventually it will charge to VDD because there is some small current flowing through, very small current, very slowly it will go to VDD. So I cannot make the statement that limit t tends to infinity of Vs of t is VDD minus VT. Okay. If I of is 0, then yes, it will go up to VDD minus VT and then cut off. Now what happens if instead of VDD, I was trying to pass VDD by 2? What will Vs of t, limit t tends to infinity, be? VDD by 2, right? So this transistor can conduct as long as VDD minus Vs is greater than or equal to VTN, right? Implies that Vs should be less than VDD minus VTN. The key point is it should only be less than VDD. It only gives you a bound. It cannot go beyond VDD minus VTN. But suppose the drain itself was a value which is less than VDD minus VTN, then obviously there can be no current flow any further after the source has charged to the drain voltage. Right? And therefore it has to go only up to the drain voltage. Right? Which implies for this condition, limit t tends to infinity of Vs of t will basically be VDD by 2. Yeah? Any question? Huh? No, earlier I didn't understand. No. You mean for VDD by 2 it will happen much before infinity? Huh? No, the thing is, again, if you look at that current equation, at some point this transistor will go into the linear mode, right? Where the current now depends on VDS. So as VDS keeps dropping, my current also will keep dropping. So that also is basically an asymptotic behavior only. Okay, so this is a correct statement to make. Okay, so how do I combine these two statements that I just made now? One is it can go up to VDD minus VT, right? The other is it can go up to whatever the drain voltage is, right? Now I'll give you another case. Let's say that this transistor drain is at VDD, Vc of 0 minus equal to 0. This thing is at 2 VDD. Then what will happen? It can go up to VDD again, right? So how do you combine these two things? So you can say that Vs of t, limit t tends to infinity, assuming that Vs of 0 minus equal to 0, okay, will go to max of, max or min Vg minus Vt, comma Vd. Here I am not saying VGS minus VT. VG, whatever the gate voltage is, minus VT, or it can go up to the drain voltage. Right? So what will happen if I do this? VDD, VDD, this is also VDD, this capacitor is discharged. So what will the node S go to finally? Huh? VDD minus why 2 VT? Yeah? It will basically go to VDD minus VT because this guy can go up to VDD minus VT. Now this guy can go to min of VDD minus VT and VDD minus VT. Drain is also at VDD minus VT, assuming that these two are, say, have the same VT, right? So therefore this will eventually go to VDD minus VT. I leave it to you to figure out in what configuration will it actually go to VDD minus 2 VT. Think about it. Okay. Similarly, what happens if I have a PMOS transistor like this? Okay, where I am going to do the following. I have VC of 0 minus to VDD. Okay, and this is going to come down to, I'm going to ground this guy, and this also I will ground. What's the drain and source first? Yeah? Drain is at? Drain is at ground. This is source. So obviously this transistor initially has a high enough VGS, right? And therefore, or a high enough mod VGS, and therefore it will turn on. It will start discharging the capacitor, but it can discharge the capacitor only until VGS minus VTP is less than 0. What is VGS of this transistor? Yeah? Sorry? Yeah, it is basically minus Vs because the gate is grounded. Minus VTP should be less than or equal to 0. Therefore, Vs minus Vs should be less than or equal to minus VTP, implies Vs mod Vs. Is this right? Sorry? Oh yeah. Plus VTP, correct. Implies Vs should be greater than mod VTP. Right? So how will you write this general condition? I have a gate voltage, I have some drain voltage. Capacitor is initially charged to VDD, right? I think this will be a little hard to put down in the general thing because it depends on what the voltages are, right? So I think it's better you just apply this particular condition that identify drain and source first. VGS minus VTP should be less than 0, and then you find out up to what it can go to, right?